Okay, let's have a look at weights. So if we look at the following graph, we have the nodes denoted by the black dots, and we have the edges represented by blue lines. And we have numbers over each of those blue lines, and they're referred to as weights. Now they could represent distance between each of the nodes, and as a result then we can just we can skew the graph to make it smaller on paper. So if we wanted to go from A to F, it might be 5 kilometers, but if we wanted to go from F to E, it might be 6 kilometers. Or they could represent tolls on bridges or the tolls on roads. So if you wanted to go from A to F, there might be a toll of €5 that you have to pay. Whereas if you wanted to go from F to E, there'd be a toll of €6. So they can represent many things. Okay, so sometimes weights are assigned to edges. These weights could represent distance between two locations, or the cost of travel between two locations, or even the time to walk between two locations. And they'll pop up again and again in graph theory. So, in this case, the weights could represent the distance between any of the two cities. In this case, the weights likely represent the dosage. So if we look at the bottom there where aspirin is, so aspirin and fixed low dose warfarin, there might be a dosage of 1 between the two of those. Whereas if we look at adjusted low dose warfarin on the bottom left hand side and aspirin on the bottom right hand side, there was a weight of 2. There might be a dosage of 2 between them. What it also could represent is maybe the amount of people taking both of these types of drugs. So they can represent many things, but they're comparative. So the number of people or the dosage between adjusted low dose warfarin and aspirin is twice as many as that between fixed low dose warfarin and aspirin. Okay. Next, directed graphs versus undirected graphs. Now this is quite straightforward. Directed graphs means you can only go in one direction between the nodes. Undirected graphs means you can go in either direction. The direction is unimportant. So the example there is Twitter for directed graphs. So usually on Twitter, you post on your Twitter feed and it just goes out to your followers. Typically, they don't reply to your post. There's no discussion there. It's just you giving information. An undirected graph even is like Facebook. So you give information and you receive information from your friends. So you can say that the information is going one way only. It goes both directions. All right. So in this case, we'll see that with directed graphs, there are arrows showing that the information or the money or the direction of traffic only goes in one direction. Undirected graphs, the direction, it doesn't matter, so it can go in both directions. And there are no arrows in this diagram here, so the information will go both ways. So the laptop in the middle is sending information to the iPad and the phone, and the iPad and the phone are likely sending information or even capable of sending information the other way. So it's a it's a graph where the information can go both ways. In this case, this is a directed graph typically. Now, if you look smack bang in the middle, you'll see Christ Church Cathedral, and just to the left of it, you'll see that the gold line and the purple line are directed down. And that just means that the tram or the bus or whatever means of transport there is going in one direction. So this represents a directed graph, meaning that the buses or the trams, or if it's a tube, they only go in one direction. Okay. The final bit, paths and cycles. So we have a graph here. We have nodes, we have edges. It's not weighted because there's no numbers over the edges, and also it's not directed, so you can go in any direction you want. Now, a path is a sequence of connected vertices in a graph. So if you wanted to go from A to B to C to D, like so, that's a path. So it's just a route that you take through the graph. And that route goes through a sequence of nodes and edges and nodes and edges and nodes and edges and so on and so forth. Okay, a cycle though is a path that starts and stops at the same point. So it's a loop basically. There we go, it's a loop. It starts at one point and it stops at another. And you can see that the cycle here, we don't know where it starts and where it stops. We just connected a sequence of nodes in a loop. Right. We also have a thing called a tree. Now, a tree is a connection of nodes where there are no loops or cycles. So it's a connected graph with no cycles whatsoever. No, that's all you need to know for now. You might need to re-watch this video a few times to get the hang of it and make sure you understand what we're talking about for tomorrow.